Hello, a very good afternoon, ladies and gentlemen. On behalf of the Indo-German Chamber of Commerce, I, Monaz Desai Tanshia, welcomes you all. Our knowledge partners for today, Schmersal India Private Limited, is a subsidiary of the Schmersal Group in Germany. It was founded in 2007 in the ever-growing market of India. And in 2010, they laid the cornerstone for a production factory, and finally, in July 2013, started production. I am truly delighted to inform you all that Schmersal is the only company having a complete production facility for safety products in India in line with international safety standards and parameters. True to the motto of Make in India, I would say. Industry 4.0 is really a mega trend that has been sweeping through the Indian industry. But that brings me also to the question, what about Safety 4.0? Have we reached there as well? I'm extremely privileged and happy to introduce you to our esteemed and, if I may say, experienced speakers for today afternoon. And they are going to throw light, or at least try to tell you how to make an accident-free workspace. So to start with, I would like to introduce you to our first speaker, Mr. Girish Alave. Mr. Alave is working with Schmersal India since 11 years and is a certified machine safety consultant from the TUV. He is Schmersal India's representative in BIS, that is the Bureau of Indian Standard, and for developing Indian Standard IS for machinery safety. Mr. Alave has conducted risk management assessment as per ENISO 12100 on machines from various sectors like food, pharma, automotive, to name a few, and provided safety consulting services to customers from India and APAC countries. Mr. Alave, I welcome you. Next speaker is Mr. Chinmay Vaidya. He is in Schmersal since 2.5 years, but has a total experience of 7 years. He works with Schmersal as senior software engineer. Mr. Vaidya, I welcome you too. And finally, our third speaker for today afternoon is Mr. Ranjit Kumar. He is the Zonal Manager West, Schmersal India Private Limited. Mr. Ranjit Kumar is a mechatronics engineer with masters in internal marketing. He is currently having more than 15 years of experience in industrial automation and safety. He started his career as an application engineer and has a wide experience in various automotive products and solutions. With over 8 years of working in Schmersal in various regions and departments like sales and business development, OEM and EU, he is now the zonal manager for West India and responsible for the entire safety solutions and business from customer safety to dedicated zones. Gentlemen, I welcome you all, and it is totally a privilege and honor to have you with us. Ladies and gentlemen, we have over 50 years of work experience put together, and I now request without further delay and bring forth our first speaker, Mr. Awal Alave, to take the floor. Thank you and wish you a good listening.
Thank you, Manaz. So just a quick confirmation if my screen is visible. Manaz, can you please help me with it?
Yes, it is.
Thank you. So very good afternoon, ladies and gentlemen. So my name is Girish and I'm working in Schmersal India with Technicum department. So I'm a head of Technicum. So basically, just to quickly share with you, Technicum is our department which is dealing with the machine safety services like safety consulting and CE marking as well as safety engineering under the brand of Schmersal. So in Technicum, we keep a neutral approach every time and everywhere. So it's not like consulting in line with the Schmersal components or in line with Schmersal's products. So when we comes to Technicum, the 4 verticals that we are dealing with, it's academy, consulting, engineering, and integration. So you can make out that this is purely with respect to the safety, engineering, and services. So 3 of our main pillar like CE services, we are offering CE services, machinery guarding, and implementation of safety in line with the ISO guidelines. So today we are going to see the main important topic on how to reach the compliances in terms of safety by keeping ISO standard and the newly launched IS standard by Bureau of Indian Standards. So when we talk about the safety compliances, so the first and foremost parameter comes in picture is a review of our own machines. So when we review our own machines, that time we come to know about some of the hazards. But are all the hazards are being covered which have been listed in the ISO standard? So to know that, we have to conduct the risk assessments. So the risk assessment is being conducted by using a safety standard, which is a EN ISO 12100. So when we move forward, once we know the hazards and risk available in the machine, we have to move forward in the project development, that is the engineering phase. So the engineering phase and implementation phase, so these two phases goes hand in hand, and here we have to refer some more standards that, like for example 13849-1. Today we are quickly going to touch both the standards and get the glimpse and some ideas of both these standards. The next part comes is a documentation. Most of the times we do all our project in terms of safety and we miss on the documentation part. So the documentation is utmost important, because in terms of documentation, the training and validation also gets covered. So a person who is going to manage the machine after implementation of safety, after meeting the safety compliances, for him it might be a new concept or new machine. So it should not cause any new hazard to them. And that's the reason documentation and training are the utmost important parameter of this safety compliance cycle. The last part is a validation. In validation, it is not only to check that whether all the hazards are mitigated, but also it is important to check that the mitigation should not cause any additional risk or any additional hazard. It should not introduce any new hazard. And that's why the validation part is extremely important at the end of this safety or compliance cycle. So once we complete the machine, so we can confirm that yes, this machine is complying with certain safety levels and it is complying with the global safety standards. So now coming to the international legislations. So when we talk about international standards or international legislations, so there are different kind of legislations available across world. But two standards, one is IEC and other is ISO, they are basically accepted at an international level. Where in case of Europe, there are EN standards. In case of Asia, for India, we have a BIS who is introducing now Indian standard, but at the same time, China is having their own GB, which is one of their safety standards. In US, the companies follows OSHA standard. Right now in India, we are following the IEC and ISO standards to develop the safety culture in India. So most of the ISO standards have been taken as a reference, and these standards are being converted into Indian standards. The most important part is India is now one of the member of ISO committee as well. So India is now giving the votes. India is also giving their request for the upgradation or modifications in the standards. So now coming to the safety standard structure, what exactly the safety standard structure is. We don't want to complicate the things. Just we have to remember in a very simple way. There are type A standards, which are a basic safety standards, which means that these standards are applicable for all our machineries, irrespective of the type of machinery. Then there are type B standards. So type B standards are applicable purely for the product. So when we talk about type B standard as a product, type B2 standards speaks about how a safety product should be manufactured. So users need not have to worry about type B2 standards. If a manufacturer is confirming that their devices are meeting type B2 standard, then user can use those products. But while using those products, type B1 standards come in picture. and users are responsible to follow type B1 standards. Now coming to type C, they are specific to the applications and they are specific to the machines. So this is just a list of standards which are provided in the type. What are the different types of standards available in type A and type B? So we can just see that the type A standards are risk assessments, type B2 are related to the products like as emergency, interlocking device, safety guards, or normally known as a safety light curtain. And the type B1 standards are how to install these products. How to wire this product is told in 13849-1. How to mount the light curtain, we will see some glimpse in this PPT as well. So type C are basically with respect to the industrial robots, which are specifically to the machines. Now, when we talk about the risk assessment, so risk assessment is being conducted by using EN ISO 12100 standard, and the process and flow of that is given in the standard itself. So the process and flow starts with the limits of the machine. Most of the time we forget the limit of machine and we want to implement the safety. But if we forget the limits of the machine, then ultimately we are going to affect the production. So normally we get a question that our production are going to be hampered if we implement this safety. The production will get hampered if we don't consider the limits of the machine during the audit or during the assessment. So the once limits of the machine have been listed down, then the hazard identification, risk estimation, and risk evaluation, this comes in picture. So once we know that risk, once we evaluate the risk and we realize that yeah, there has a potential to reduce the risk, so then the risk reduction comes in picture. Now how we can make the evaluation? The evaluation has been made by using a hazard rating number. So the hazard rating number tells us whether the risk has to be reduced or risk can be accepted or it is a low. So in this sense, when we talk about the risk reduction, there are always three techniques. So if you see in the slide, this is the crushing point. We all know that there is a hazard, a finger can get pinched. But when we talk about the safety, you can change the design of that component and you can save your finger here. But in case if that design change is not at all possible, then one has to provide a protective measure against the pinch. The last option is if that protective measure is also not possible, then you can put the signages and warn the people that yes, there is a hazard, there is a risk, and you have to keep yourself away, you have to protect yourself from that particular risk. So the common thing is avoid the hazard. If you can't avoid the hazard, you protect the hazard. And if you are not able to avoid and protect the hazard, please indicate the hazard. These are the three methods by using we can reduce our risk in the machines. So coming to the mitigation techniques, so there are many ways to mitigate the risk when we talk about the protective measures. So the protective measure is a part that can be used for the implementation in terms of safety safety at the time of designing the machine, also at the time of using the machine. So anyone can use these key measures or safety measures to mitigate the risk. So it is like install the fencing or install the fence with the necessary safety equipments like door interlock or light curtain or scanner. So there are n number of ways we can reduce the risk, and these are the only ways available. However, when we go for these all ways, it demands a safety function, means we need to install these all components in line with the safety guidelines provided in the ISO. We need to install all these components in a proper way to meet the safety compliances. So these are some of the products that we have shown here. So this is basically to get the idea on what standards are applicable for which product, these are commonly used product in the industry, like emergency stop 13850, safety fencing or machine guarding, it always deals with 14120, door interlock is having 14119. So these are the common products which have been highlighted and the standards are applicable for these products. Now we will take one small example of light curtain, because light curtain is normally known to many of the people. So when we take the example of light curtain, or when we want to install any light curtain, we need to ensure whether light curtain is really effective to use on that machine? Because if you see in couple of images here, if a light curtain, you can reach over, you can reach under, or you can stay in between. If the installation of the light curtain is formed in this way, then light curtain is of no use. Then we need to ensure that light curtain is placed in such a way that if person try to access the machine, then the light curtain must get interrupted. So here we have to follow a safety distance standard, which is a EN ISO 13855. Now at the same time, we also need to ensure that whether light curtain is installed at a safe distance or not. So for this, stop time measurement comes in picture. So whether it's a light curtain, interlock, safety mat, or any type of safety device, we can perform a stop time measurement. Stop time measurement means before machine comes to standstill, if a person can access to the motion, then that safety device is of no use. So that safety device must perform its function in such a way that a person should be able to access the machine only when it comes to standstill. And that is what is the simple definition for stop time. So stop time measurement is required in terms of light curtain, mainly in terms of light curtain, because light curtain is basically a device where we have a high approach speed. High approach speed means because there is no physical barrier, so a person can access the machine without any physical barrier. So that's why the light curtain is one of the device which has to be placed in a proper way. Most of us use the light curtain, but light curtains are not placed in a proper way. In Schmersal, we have one light safety distance calculator software available, which is free of cost, and that software can be taken to understand at what distance light curtain should be mounted. So audience can always take this as an advantage, and audience can use this software for this kind of for installation of light curtains. So this is a list of standards which is released by BIS. So there are total 32 standards have been adopted in India. So now onwards, earlier the Factories Act was there, but there were no such guidelines on how to meet the safety compliances in India. Of course, they are available at ISO level, but they are not available in India. But now such safety guidelines and compliances are already available in India, and they are equivalent to the ISO level, and hence it has been asked to follow these standards in India. Sooner or later, they might be also make it mandatory, as like in Europe and US. So we will just take a quick overview of 13849-1. So a 13849-1 software standard asks us to calculate what safety level we have to reach in terms of machinery safety. So what safety level our machine or our safety function is demanding. So this chart is available in this software, in this standard, and this particular chart deals with severity of the injury, frequency to the particular hazard, or exposure time to the particular hazard, and possibility of avoiding the hazard. So for example, if we know that there is a very severity is very high, we normally go with the S2. And if we know that frequency or exposure time, here I want to clarify that frequency means if you are accessing once per 15 minutes, then your frequency is always considered as a high. Or you are getting exposed to that hazard for a longer time, even if you are appearing once in an hour, but you are getting exposed for 10 minutes, 15 minutes, then also in that case, the frequency is high, that is a F2. And now the last point is a possibility. If we can avoid this particular hazard under specific conditions by using some protective measures, then we can mention that we have to reach performance level D. So S2, F2 and P1 was the flow of our requirement. In this way, you have to calculate the required safety level for each of your safety function. So what is safety function? The safety function is your input, logic and output. Input is your safety devices like light curtain, door interlock, emergency stop. Logic is nothing but the safety relay, safety controller, or any safety logic device. And the output is normally a contactor. So any type of contactors having a positive guided contacts. So they are considered as a output, or a drives which are having a STO functions, which are having a safety functions inbuilt in it. So they can be considered as a output. So now how we assure that safety level is achieved? So for each of these device like input, logic and output, there are certain PFHD. PFHD is nothing but the probability of dangerous failure per hour. So a manufacturer defines this PFHD value, or a user can calculate these PFHD values based on their usages as well. So the summary of these performance level subsystems and the calculation is the sum of all these PFHD values defines the PFHD for our entire safety function. So when we talk about summations, the summation is with respect to the performance level of input, performance level of logic and performance level of output. So the summation of these three will guide us whether in which safety level we are falling upon. So ABCDE, there are certain guidelines given in the standard, and with respect to that guideline we can monitor whether we are reaching to certain performance level or not. The last point is safety circuit evaluation. We all implement the safety, but we normally do one small mistake. In the previous slide we have seen there is an input, logic and output. So the here in the next slide you can see this light curtain as an input, safety PLC as a logic, and a motor is as an output. So a safety sequence should not have any non-safe component introduced in between the complete safety path. So the if we have a normal PLC, then that normally the people gives us output of a safety controller to normal PLC to drive the main function of the motor. So tomorrow if this PLC gets failed, then our entire safety function is of no use. And that's the reason normally the sequence followed is the light curtain, that is a safety input device, the logic and the output. The output is controlled by the complete safety controller and not by the conventional controller. So this is how the safety circuits are need to be prepared. So with this we are just giving an overview. It is very always difficult to give an overview in 10 to 15 minutes, but this is an overview of all the safety compliances, majorly 12100 standard and 13849-1 standard. Now in next session we have our engineering expert Mr. Chinmay, who will be speaking about industry 4.0 and how we are going to meet the IoT solutions. So Chinmay.
Thank you, Girish. Please present. Yes. So hello, everyone. So as Girish told about the importance of, touched upon the importance of Industry 4.0, I would like to give you a brief overview about Schmersal's Industry 4.0 solution. For next. Yeah, so we'll just go over the Industry 4.0 basics of the first, then we'll try to understand what basically is safety in the era of Industry 4.0. Then we go over the architecture of our current solution, and we can have the preview of the solution as well. So next slide. So I'll just give you a brief overview about the component system for Industry 4.0. So whenever we talk about a component, it is basically an object with data which is not equipped with intelligence. So with Industry 4.0, the main basis of this industrial revolution is to aggregate as much data as possible and try to analyze the data in means that it is actually relevant to us in terms of increasing efficiency, in terms of monitoring. So with the object, we have the next step, which is cyber physical systems. So in the automation pyramid, it's visible here that the lowest layer is basically the field devices, and then we have a control layer, and then we have enterprises or spanning layer where the data aggregation happens, and then a lot of devices can be together connected in terms of an automation network, and which can be remotely monitored. So these whole system basically constitute the Industry 4.0 component system. In the next slide. Yeah. So next slide basically we'll go over what exactly is the asset diagnostic shell and Industry 4.0 compliant communication. As we all know that we need to have devices sending the data, but we need to ensure that the data matches our requirements in terms of what we need to show as relevant. So the data which the devices need to send in terms of Industry 4.0 compliant communication is basically the design manuals, the drawings, the runtimes, as well as we need to observe standards like knowledge of the component, features for data functions, as well as we need to have the networking between the data and information in order to constitute the diagnostic shell. So as you all may have heard a bit about digital twin concept. So digital twin is basically a virtual identity of the device in which all the parameters of the device can be replicated. So that is basically what the asset diagnostic shell for Industry 4.0 compliant communication is. So for the next slide, we can go over the safety in era of Industry 4.0. Yes, so as you can see here in the information pyramid, we'll try to correlate what exactly I mean by safety in era of Industry 4.0. As you can see, the lowest level is basically the field level where we have actuators or sensors. The second level is the control level, and third level is the process management level. When it comes to our devices, the field level devices are, as Girish had mentioned, for example, a safety light curtain or a solenoid interlock or an RFID switch. These basically constitute the field level, which are the field level sensors. The control level consists of our safety field box as well as safety controllers. So these both constitute field level as well as control level. For the next slide, please. Yes, so this is what the Schmersal Safety Industry 4.0 component system looks like. And then, now that we have those devices and the data, we have a control layer where we aggregate all the data on a virtual PLC and push that data to cloud. So by doing this, we are able to aggregate the data, analyze that data on a controller, and then try to understand what type of data is relevant to us in terms of increasing efficiency, in terms of breakdown maintenance, in terms of predictive maintenance, and push it to the cloud where we have capabilities of monitoring it remotely over a remote network. So this is basically what safety in era of Industry 4.0 is. Next slide will go over the current commercial solution which we have. Yeah. So right now, as you can see here, we have commercial devices connected in a network inside a factory. So as you can see here, these are basically the control level devices. For example, a safety controller or or a PLC or ILink safety device or a SLC. The data from our devices like SLC or RFID switch or solenoid controller is basically aggregated on these controllers, and via Profinet communication they are sent to the PLC. PLC is where the business logic is also implemented, and by using OPC UA communication we send all the data to an edge gateway. So inside the factory is basic. There are two ways to look at the monitoring system. One is inside the factory where all the data is analyzed and visualized on premise in the local network. So in that case, the data analytics and visualization is done on the edge gateway itself, and any user which is connected on the local network would be able to visualize the data on his system. Another path, if you have to look at it, is basically the cloud. So all the data which is aggregated on the edge gateway is sent to a Schmersal cloud, which is in Microsoft Azure, and that data can be remotely monitored according to the user credentials. So this is the current solution of architecture which we have. In the next slide, we will have a brief overview about the analytics. Yes, so current analytics we have for a solution is we have standard and derived operating data for our components. So on the dashboard, you can have a look at the number of operating cycles for each individual device, the counter for errors and warnings. And we also have implemented anomaly detection. So basically, anomaly detection is what is the uncommon way in which the device has been activated, how long it has been activated, how often it has been activated. That can be visualized on a graph, and that can also be customized in form of how much time we wanted to analyze it. For example, I just want to see this graph for 1 week. That is possible. I want to see the historical data for more than a week, a month, and that is also customizable in terms of the dashboard. The deviation from normal state is also possible. Then for components which have latching force, for example, a solenoid interlock, the parameterization of the latching force is also possible. So that is possible on premise for security reasons. You will not be able to control the latching force or parameterization for the components if you are connected via cloud, for example. And apart from that, we also have status and diagnostic data, error and fault warning. So what type of error, what type of warning has occurred in the component, that is also visible on the dashboard. So these are the analytics features which we have in our solution. For the next part, we can go to the dashboard where you can have more idea about what exactly or how the solution currently looks like. So this is the Schmersal Safety Cockpit, where it's a web-based application where all you have to do is type in the URL, and with the correct credentials, you can access this dashboard. Right now, as you can see here, this is machine 1 and machine 2. So machine 1 has all the OSSD devices connected to it, and machine 2 has all the SD devices connected to it with our safety control. As you can see here, that the status here shows green, which tells us that the machine is up and running properly. If we have to deep down into what type of components that machine has, we have to click on that green light and it will take us to the next page. Yeah, so the next page is where you can deep down into what type of components are on the machine as well as their status. So as here you can see we have an e-stop switch or an RFID switch or a solenoid interlock which are connected to a safety controller. You can see the status of each and individual device here, and also know the status of the machine here. So machine is ready, machine is running. So this is how you get an overview about the machine status. If you want to deep dive into each and individual component, you can click on the green LED and it will take you to the next page, which is the overview page. So overview page is basically where you get all the details about each and individual component. As you can see here, that each and for example, MZM100, or we have RSS36, which is a RFID, and PDF200, which is an e-stop switch. So here you can see the status is displayed, as well as if the door is closed or if the door is locked, then the number of operations, the number of errors, as well as in case of solenoid interlock, the latching force, as well as ability to lock and unlock the switch on premise. So that is also possible. On the left side, we have a navigation panel. If you want to navigate to the safety cockpit, or you just want to have an overview of the full machine, that is also possible. We also have a graph for health check. So anytime there are errors and warnings, the health check here would display that the machine is not running properly and what type of error has occurred in the machine. So that is also possible. In the next page, yes, the next page is basically a detailed view about warnings and errors. As you can see here that each and individual error and warning is displayed according to its occurrence. So here you can see that the magnet temperature high warning is occurring in the dashboard. Similarly, if it's an error, we can have a crosswire error or e-stop button error that can be displayed on the dashboard itself. So the detailed analysis of the warnings is also displayed on the dashboard. In the next page, so in the next page, we also have a comparison for status of the switch gears as well as the machine operating status. In the top drop-down boxes, you can you can select machines. So, for example, I want to see the status for machine 2, that is selected. Then you can select the device you want. Then you can also select the type of data you want to see, for example, status data or operating data. And then you can compare these data in terms of switch gear. So The drop down for status is here is shown here, where you can see the status for all the parameters of that specific component, and that can be compared with the machine operating status. So this can be done in real time as well as historical data. So the first three were basically the first three dashboard slide, the first three dashboard pages were basically about real-time data, and now here we also have historical data which is stored in a database in our system, and you can view the data for, for example, over here it is written last 5 minutes at the top right corner. So that can also be like last 1 hour, last 1 week, last 1 month. That can also be visualized. In the next page, yes. So next page is basically about anomaly detection. So for here, you can see here that you can select the device you want as well as the type of analytics you want. You can also select the time frame to group those analysis by, and over here select the time frame of data. So this is what I was talking about in the last slide. This is where you can select the amount of time for which you want the analysis to happen. So this is the data which we have for our RSS 260, for example, and as you can see, the number of door openings depending upon the time. We also have average number of door openings which is visible in the bottom right corner, and by that we can visually see the number of anomalies which are happening in that time frame. So this is the screen for analytics or anomaly detection. In the next page we have the alerts page, where you can individually see error or warning alerts for all the components. So this is basically the page where you see all the components. So whenever there's a green heart, the component is working just fine and there's no need to worry about it. But anytime there is a a breakdown or if there is another new component, it will indicate that error with a broken heart on that component itself. So it is easy to pinpoint that this component is having an error, and uh, it helps save time when it comes to the breakdown maintenance part. For the next page, we also have a functionality for alerts and Microsoft Teams. So as you can see here, anytime a component, an error occurs, it gives you a message in Teams that this is the error and this is the error or warning alert and this is what the error is. So anytime you don't even need to have the person sitting in front of screen trying to visualize that. Anytime an error occurs, you can always get a notification in your Teams. And after the resolution, you also get a message that this error has been resolved and the component is now working fine. So this is also one of the more important criteria which we have in our solution. And for the next, this is it from my side for the Schmersal Industry 4.0 solution. Thank you, Girish. I think Ranjit can follow me on this.
Let me know once my screen is visible.
Yes, it is.
Monas? Yeah.
Yes, it is.
So, yes. Thanks to Girish and Chinmay for a wonderful session. And you guys have shared good data related to the latest standards and how IoT structure has to be. Yes, it's good to go now. So I'm welcoming everyone for Industry 4.0 man and machine safety automation. So Schmersal is 75 years old company. We are marching towards our 80 years. And you can see we have established ourselves in 1945. It's a German-based company. This is how we have spread across the globe. You can see. And we have 4 plants in Europe, 1 plant at China, 1 at America, and 1 at India. That is at Ranjangaon. Yes. So this is a theme actually. Schmersal as a company with 75 years of experience, we are catering more than 40K customers across the globe. We are having 7 manufacturing facilities to manufacture 16,000 products to cater the industrial requirement by keeping one goal as a common, to address the customers for their safety and system solutions and ensuring their workplaces working safe. And we are aligning ourselves towards the industrial requirements of IoT, Industry 4.0 or IIoT or whatever. Yes, this is a footprint of company since 2007. You can see, we started in 2007 in India with 3 employees. Then our manufacturing plant got constructed in 2013 with 40 employees. Then we have our own export-oriented unit and free trade warehouse zone in 2017. And we have our global IT center by 2018. And we have our global engineering center by 2019. And by 2020, we have our EOU expanded. And by now, we are 150 employees. Yes. This is our plant at Ranjangaon, Pune. This is the eagle view of the plant. Yes. Now we are coming into the core topic of what is Industry 4.0. Generally, people think if it is Industry 4.0, it is IoT, but it is not right. I can say it is a tricky phrase. Industry 4.0 is a tricky phrase. You can achieve Industry 4.0 with several tools. So IoT, Internet of Things, may be a tool, one among them. You have a multiple tools or multiple concepts or multiple phases. So you can see all these 9 pillars contribute a concept, okay, which includes simulation, system integration, 3D additive manufacturing, Internet of Things, augmented reality, autonomous systems, cloud computing, big data, and cyber security. So by this, what I want to communicate to you people is Industry 4.0 is a concept, not a product. So you can achieve Industry 4.0 either with Internet of Things or with Internet of Things plus multiple phases, what we are showing here. Yes. Now coming to Industry 4.0 or IIoT, how people do in industries. It is a combination of industrial IoT, how you are networking your devices, maybe which starts from your sensors, motors, whatever, how you are monitoring your tools, for example, energy analysis, energy monitoring, kind of the data, how you are synchronizing your automation into the loop. Again, safety has to go one-to-one with all these tools to have a proper nutshell of Industry 4.0. If you are aligning safety into the nutshell, then you will be having a quality stuff to cater the multiple application to align yourself into the standards. Yes. So what is the future? Now we are speaking about Industry 4.0, smart factory, so many things. So by this, what we are going to do in future? By this, what we are going to achieve in future? What is a pain point? What is a bottleneck right now? You see, monitor production flow in real time to eliminate wasted time and reduce in process inventory. This is right now we are doing this, but not automatic. So whatever we are doing right now, it's a random stuff. It is not a real time data. Then one more thing, manage equipment remotely using sensors and limits to conserve energy and reduce cost. Now what everyone is doing in industry, they are working in industry. If something forms faulty or something found failed, what they will do, they need to test it, they need to go there physically to identify what is happening. Then they will be checking in the stores whether the product is readily available or not. If it is not available, they need to go to their purchase team to ensure they need to get the product in a short time. Everyone is aware what is the latest crisis happening in industry due to electronical chip shortages. So there are many things associated. So in future, in order to overcome these things, IoT will be playing a major role. If I mean IoT, which is, as I told earlier, it's a nutshell, it will be of a multiple factors. Okay. Then production line triggers autonomous metal handling vehicles. Now, what is happening? Let us take an example of one packaging line. Okay. So you will be having a packaging things getting moved from conveyor. What happens if your systems are not automated to deliver at the end? So you will be having a piled up stock. which due to that you need to slow down your the further production of the activities. Due to that, entire system has to be slowed down. This is completely a manual process, right? So this will take a lot of energy, lot of time, lot of involvement of some key peoples. If you have automized your things as per IoT or Industry 4.0, I will explain what if I mean Industry 4.0, that I will explain in later slides. But if you automize everything and align yourself to Industry 4.0, then we can try to mitigate this kind of bottlenecks. But again, I'm telling you, this is not a simple thing. So this may be new to many. It may be already we are doing a part of it. It's only of a matter of time, I can say, how we are fulfilling certain requirements to form an entire flow. Yes, if you are having a proper IoT into your factory or industry or whatever, you can see here multiple stuffs: smart automation, robotics and motion control, and IO handling, intelligent edge nodes, and smart mesh for industry, robots, cobots. You can see it is not that IoT is going to reduce the manpower. It is going to give us an option to use the manpower in a optimized and effective way to cater the applications. For example, you can see there are peoples, for example, right? What they're doing, they are giving a command to the system how to operate. For example, they may be collecting a data from the devices which is on a real-time data to cater the application to ensure everything is happening on a right time, on a right node actually. So which means everything is synchronized, right? As he is giving a signal to the system to get the things done, system is working on its own and giving this feedback to the network that will be connected to the server to get the detail across the loop. Okay, this we can say as seamless communication of the network, where nothing has been stopped at anywhere. If something is going to stop, there will be a real-time data why it is going to stop, what could be the countermeasure to ensure the working of the unit or device or whatever. Yes, with Schmersal, what is our capability or what we can do with safety technology to the customer and aligning ourselves to Industry 4.0. For example, many customers use IO Link. We use RFID technology products. We use Bluetooth enabled devices, and we will be using serial diagnostics bus to connect multiple devices to ensure proper topology to get a communication network. Yes, in safety, people used to use multiple devices, multiple units, multiple sensors. But end of the day, if someone question them, are you adhering the safety? They will say, yeah, yes. But whatever the devices you are using, it has to be sensible and proper data has to be collected and it has to be used in a proper way to get the data. For example, simply I can say the sensor has to be intelligent or smart itself to identify why I am stopping, why I am running, why there is an error. It has to trigger on its own to give a feedback to the controller. This is one of the bottleneck right now we are having. Then, whenever there is a maintenance, whenever there is a issue at the shop floor, for example, supervisors or manager who will be sitting at a different place, they has to address the requirement. Now you look at the current technology or current era, what is happening? They need to rush to the shop floor to see what is happening. But your sensors, your equipments, your devices has to be smart enough to give the feedback to the controller to raise an flag saying that I'm having an issue, I'm having this kind of an issue, my issue is due to this. That kind of a technology has to be addressed. Then whenever there is a address of issues, whenever your sensors or your devices are smart enough to call its own error, then you can ensure that your maintenance activity is going to be taking very less time. I can say the downtime of your machine going to get reduced. So whenever people speak about IoT, many of the times they keep safety as a third part or a third grade, or they are not ready to integrate into the machine sequence. But the world is moving towards an era where safety is also going to be a part of an IoT. Safety has to go hand to hand with your production, maintenance, and every department to ensure proper networking. Yes. Then one more thing. If you see, for example, system integrators, or you may be a machine builder, you may be a panel builder, whoever. But in terms of safety, the wiring plays a major role. Many people say I'm unable to, as my machine is very big, I'm using lot of sensors, lot of devices, lot of networking, IO-Link, RFID, so many things. But end of the day, when the machine is going away from India, we found it is very tough to monitor. We found it very hard to ensure where the machine is working, what is happening, whether all the wires are connected properly. We are simply, I can say, they are finding it very tough to troubleshoot from remote, because due to this COVID days, it is not very easy to travel between India. Okay, there are people who supply the machine outside India. If a customer from Europe calls you to send your engineer, it is not very easy. So you should develop a tool to monitor what is happening your machine remotely. That we can help you with the expert eye. This is what you can see. If such a tool has been developed, it will be helpful for everyone to address, at least we can address the query on remote to find out what is happening. It will solve at least 50%. It is not sure it is going to solve 100% of your issue or problem, but we can ensure that it is going to give you some idea what is happening, what is missed out, what has to be done. Yes, in safety, where the if you mean safety, where the components are going, wherever the safety components are implemented in the machine, where there is a protection of some units are happening, right? Otherwise, why people need to consider safety? So in safety, there are two things which plays a major role in terms of maintenance: productive maintenance and productive maintenance. As on date, you see, no one is following this productive or preventive maintenance. Whenever there is an issue with the product, no one is ready to see how long my product is working, how long my products are getting activated on, off, nothing. They just want to ensure their production. No one is ready to see what is the healthiness of the product. If you have a fine system to monitor your device, like I'm working for this many hours, I have operated this many times, my lifetime is this. If your device is having a capability to raise an alarm about its lifetime, then I can say it makes our life very easy and simple. You don't want to worry much over it. Further added into it, if a system is eligible or capable to address its own lifetime, and if you are able to communicate that, capture that data into your SAP or your ERP systems for an automatic ordering of the barcodes, then you can say no one want to discuss about products or alternatives or prices, nothing. That the system has a flow and it will go on its own. Yes, this particular slide shows how we are going to connect multiple units of third-party devices in our topology to connect to our system and take the information from our system to the cloud network or whatever. You can see here, there are multiple devices. I can say safety light curtains, safety sensors. Okay, for example, we are connecting in some industry. If you see, people rely only on IO-Link. Okay, there are different ways to address if your devices are not having IO-Link. There are, you can see limit switches here, you can see proximities, you can see RFID switches, you can see basic electromechanical units. So we are connecting entire units into our network, and finally we are giving the feedback to your devices to connect it to the master PLC. So what this shows, the connectivity of the devices has to be proper. It has to be with anything. For example, it has to be IO-Link, or it has to be safety field bus, or it has to be Profinet or whatever. But you in IoT, you have to ensure that you are connecting all your devices in a proper topology to collect the data. Then after collecting the data, using the data in a sensible way and transferring the data to your cloud, your cyber security agents clouds, that matters a lot. You see how a typical connection of field units to the controller and how the data has been transferred to the server from there to the network. You can see here the devices are connected to the controller. From there through OPC UA, it has been transferred through the cloud network. From there it has to be transferred to the server. So whenever you may be working at a remote, you want to monitor what is happening at your site, you will be having a dedicated application to see what is the production of your machine. You will be having a dashboard kind of a setup in your app to see what is happening. So whenever this kind of system is there, your life is going to be easy and everything is going to happen on time. Now this will be little new, or I can say the world is moving towards this. Now everyone is aware about what is home automation, but what is the future? The future is in home automation. It is going to, for example, some elder people are there in home. If no one is there, how elder people are going to take care their activities on their own? This configuration shows it's a future of home automation even in India. It includes how wearable sensors for elder people, how you are going to monitor their activity to some activity direction sensors, how you are going to monitor how long they are going to sleep, wake up. Then if they want to come out, you need to monitor your environmental conditions also, right? Whether it is sunny or it is rainy or it is cloudy, whatever, that is also going to get monitored. Then your home should have a proper security system, that is also going to get monitored, and data is going to get collected, and it will be that the data is going to push to the cloud, and from there to the certain applications. This includes even management of the energy. For example, you have a refrigerator, you have multiple electronic devices, home appliances in your home. You need to monitor everything, which is also part of this automation or IoT in future. This includes one of the crazy thing I can see. It looks crazy now, but it is going to happen for sure in future. You can see emergency. Whenever elderly people, they feel uncomfortable, they feel emergency, how they are going to raise a flag. This is also part of a future IoT in home automation. Yes. Now I can say, what is IoT? IoT is all everything for future, which means integration or communication of the multiple smart devices. It's a artificial intelligence is also part of IoT, a smart factory. Augmented reality, which is going to play a major role in future. It is already happening in India as well. Then your system has to be autonomous. It has to work on its own without any dependability on others. Plus, cyber security has to play a major role, because we are going to speak about a lot of confidential things, credentials, so many things. So you need to ensure that your network is protected properly with the help of cyber security. Monas, I can see my system got hanged.
Just a sec. I will share the screen sharing option with you again.
Yeah. Can I go ahead?
I think there's a problem with your laptop.
Can you stop the screen sharing? We are just making a troubleshoot.
Yeah, sure.
Yeah, Monas, can you try now?
Just a second.
Yeah. I can see another 3-4 slides to end the discussion. Let me know once my screen is visible.
Ranjit, this is Sana here. I have shared the screen sharing option with you again.
Okay.
We can see your screen, but it's blank as of now.
No, yeah, that is just a
Yeah. Yes,
yeah.
we can see the transition. Perfect.
Yes. Yeah. So cyber security plays a major role in IoT. How you want to connect your multiple devices, how you want to add your communication credentials, so many things into your cloud computing. Then system integration, it has to be automatic. If you want to develop a unit at a site, you should be having a possibility of option to simulate without a physical of components. For example, you are going to prepare automotive line. Okay, so you cannot have everything online as on day. You will be having proper plan, you will be having an idea, so you have a proper system to see and simulate each and everything before the plant come or before the plant which is going to get manufactured something. Yes. Then autonomous systems, this is what I shown earlier also. So now you see what I'm showing here, it is going to be the future. Or already the company like Tesla or Apple, they are already in a process of doing this, and they have implemented in testing as well. Yes, last but not least, IoT is not only Industry 4.0 is not only Internet of Things or augmented reality or whatever. End of the day, it is transfer of a seamless data from point to point. It has to be in a synchronized way with the multiple applications in your system. That is known as cloud computing and edge computing. So end of the day, I'm repeating again, IoT is not a product, it's a concept. Okay, you can achieve Industry 4.0 maybe only with IoT, maybe not only with IoT, IoT plus augmented reality, artificial intelligence, automatic synchronization, so many things. So that's how I'm completing my session. Repeating once again, IoT is a concept. Yeah. Thanks for listening. Now we are moving into Q&A.
Thank you very much, gentlemen. Thank you very much. We do have quite a few questions all lined up for you guys. So I'll start with the first one. It's, I think, in two parts, but first is kind of a yes or no. So does Schmersal supply area scanners? And the second one is that how can Schmersal ensure its presence with the design software developers for robotic simulation and plant layout for integrating the safety aspect right from the design stage? So the floor is all yours.
So addressing your first query, yes, Schmersal, we do have safety scanners. So we can address all the requirements related to safety scanners, laser scanners. Coming to the second question, Girish will address this.
Yeah. So coming to the second question, basically how Schmersal can support. So in terms of support, Schmersal in Technicum division, we have a team of certified safety consultants, and normally the safety implementation starts with the machine design stage. So it will go on like a design of the machine, like a design risk assessment. Then the second stage is a risk assessment when the machine is ready for trials, and the last is the validation when your machine is ready for the production. So in all three stages, the audits will be performed, and at time to time, the necessary inputs will be provided to the machine manufacturer as well as to the machine user to make necessary changes in their requirements in their machines in line to meet the safety compliances.
Thank you, Girish. Thank you, Ranjit. I'll quickly move on to the next one. How to drive motivation in labor workforce for safety. This is really a good one.
Okay. So if you see the industry before 5 years, where safety is not a part of anything. Only people from HR, they used to drive what is safety, how it has to be. If you see the latest norms and latest with industries, every industry is having their own safety managers, safety specialists into their own company to address the requirements. Then one more thing, people need to understand that safety is a part of their own life. It's a mental behavior. If they are not thinking that safety is an optional, then no one can save them. People need to understand safety is a part of their life. Then things will come automatically into the picture.
I just would like to add here, Munas, that when we talk about machinery safety, earlier it was like a theoretical subject, but nowadays there are many softwares are available. There are many different type of configurators are available that actually create a lot of awareness in terms of machinery safety, and that will help us to create that motivation to the people that to implement this in their premises. And basically these softwares are available free of charge. So there are 2 to 3 softwares. I have mentioned one of the software for light curtain installation, which is available free of charge. So in the same way, there are different kind of softwares available for calculation of safety levels. So that software is also free of charge. So these basically softwares, because nowadays now no one want to go and read the book in the theory. So definitely young generation prefer to see the softwares. Young generation prefer to deal with kind of a technology, and that has been already available in today's world. And that basically right now in machinery safety, they are available at free of charge, which people can use, and they can definitely motivate their team and their workforce for this.
Thank you. Thank you so much, gentlemen. And if I may just add that I did some reading and found out that certain industrial surveys, they suggest that people who have been working on a certain machine or their job for over 20 years are more likely to be the first to have an accident. Would you say that is true, that the longer we are on the job, it is easier to become complacent and take safety for granted?
It's true, but it is not always. Like those people are well aware, and if these people would like to adopt a new technology, then they will not face such accidental issues. Yeah, but if they obviously, if a person becomes overconfident, then it's always a challenge, and it's always a you can say they will end up in trouble.
Thank you. Moving on.
I will add one more thing. You see, before I will add one more thing. If you see several years before, safety is nowhere into the picture. If you see now, safety is more than optional. If you see future, safety is going to be mandatory. So when the thing is going to be mandatory, this kind of accident and related to the things is not going to happen. So that is one point.
Thanks, Ranjit. Next question. Does Industry 4.0 require any changes in machine? Do we require to keep any provisions in machines to connect with Industry 4.0? And how much time of breakdown is required to connect with Industry 4.0?
So typically Industry 4.0 requires a lot of changes in your machine if your machine is old. If you're going for a new machine, or if you're having a concept or idea for future IoT or Industry 4.0, you need to select the components, equipments, devices in such a fashion that all the selection is having some capabilities to address and communicate with my devices. If you are able to select in such a way, then we can say the time to the field is going to be very down. Then one more thing, right now we are in a position that we cannot ensure, or we cannot say how long it is going to take. It is again depends how long the machine is, what is the size of the machine, how old the machine is, what is the device, so many things.
Yeah, I just want to add one more thing with what I agree with what Ranjit said, and for the how much time we need to require for breakdown for Industry 4.0. Basically, it depends on what type of devices are connected on the machine, what type of data you want to analyze from that machine, because that is also relevant while specifying which devices are required on the machine, as well as what type of communication protocols are needed.
Thank you. Thank you, Chinmay. Moving on, is there any adverse impact on machines or people in case of any abnormality in the Industry 4.0 system?
Yes, if you see the technologies or latest things, as I shown my PPT, there are many tools. For example, augmented reality. I'm speaking about the future, right? Augmented reality, autonomous system. So whenever there is abnormalities or sensed by these devices, which is fitted in the ground, they will be raising an alarm before the abnormalities. There are with this kind of facilities and features, that's why the company like Tesla or Apple, they are moving for a automatic car drivers kind of thing. Girish want to add some more thing into this.
Yeah, so basically these softwares and our industry 4.0 data is always used for making the analysis, and that analysis always helps us to know in advance. Like we say now that prevention is better than cure, so always it prevent us to, and it will tell us in advance that okay, this device you may need to change, or this device you need to address in next couple of months. So this will helps us in terms of to get the information about the device healthiness in advance.
Thank you, Girish. Next
Yeah.
question, how to train shop floor employees for safety?
Yeah, so basically when we talk about shop floor employees, usually there are different kind of training modules an organization should have. So a one training, it cannot be having a one training module for all type of people. So when we talk about operator, they must have the different kind of training module. When we are talking about an engineering people, or we are talking about the maintenance people, they should have the different kind of training modules. Then when we talk about the project team, they should be having a different kind of, so there has to be a different kind of training modules. We cannot generalize these kind of training modules for all type of people in a one go. So this is what is basically in terms of making the shop floor employees more and more trained on the safety. Yes, the behavior is more important, so these people requires a behavioral safety training. So when we talk about the technical people like engineers, or we talk about the project people, they are more into the functional safety related parts. So the each and every person in the factory, there has to be a differentiation in the trainings what we are providing to the what we are providing to them, and there has to be a different training modules which has to be prepared by these companies. Maybe they can take a help from some of the industry expert, and yeah, Technicum can also be one of the solution provider for them.
Thank you so much. Girish, please let us know when you would like to take the last question. There is one more. What is the major difference between smart factory and Industry 4.0 concept? Would you like to take this live?
uh,
Yeah, sure.
okay.
So basically, it is similar to Industry 4.0 and Smart Factory. They are basically correlated. So Smart Factory is where you have all the process data as well as production data, and then you are doing all the analytics as well as visualization on the premises. Apart from that, all the data which is related to process production, which is on the system, that can also be connected to a server which is on the cloud, basically. So those both concepts are interrelated. There's no major difference. I hope that answers the question.
Thank you very much. We have perhaps one last question that we can take up. That would be, mm, what is the best safety process in an aerosol manufacturing industry?
So when we talk about a specific industry, then that has to be referred with the different kind of safety standards. So I think we can answer this question when we refer to the specific application in this industry, and then we can answer this question. So as of now, we can skip and we can move ahead, Monas, but
Sure.
you can share our details and we can answer this question.
Absolutely. And perhaps the last one, can you talk more about transferring data from the field level measurement and control systems to the cloud through the gateway? Would that be possible?
Yeah, if you want to capture the data from field level sensors and give the data to your control level, it is possible. There are quite few methods. For example, some industry use IO link kind of concept. Some industry use a serial SD bus. They used to say they use that kind of concept. Then some people use a field bus. So there are multiple ways to transfer or collect the data from your ground level or sensor level or field level, but your sensor should be capable or should have the feature to transfer the data. That should be the primary one. Chinmay, I'm giving to you. You also add something related to this.
Yes. So, as Anjit said, the main assumption here is that all the devices are capable of communicating on all the layers. So, I'll just give a quick overview about what I think he wants elaboration on from Akash. So, from the field level devices, we have devices like our sensors, and then on the upper layer, we have control devices, for example, our PLCs, where all the data is aggregated. Now, when it comes to the PLCs and on-premise data analytics or visualization, there are two methods to do it. We can develop a business logic on the PLC itself. So Akash might have heard about the ladder diagram, the ladder logic on the PLC itself, on the inputs we are getting, as well as for on-premise analytics, we transfer the data maybe by Profinet to edge gateway. On edge gateway, there's a provision for setting up a connection to the cloud. Uh, right now, its popular protocol is MQTT and OPCU, as you might know about it. But on Edge, there's a provision for developing a database as well as doing analytics on the database itself. So we also have historical data, which is possible on the Edge device, or we can send the real-time data directly to the cloud, where we can store it in a database in a cloud. So in terms of the data transfer, we'll always be having a real time. There will be a parallel path, like we will always be having a real time data for our devices, which will always show status data. And then we'll also have a historical data, which is required for analytics. For example, right now, if we have two devices, then we can have the data analytics or the data transfer towards edge gateway and on-premise is good. When we talk about a lot of devices or the concepts of big data, that is when we have to transfer all the data to a cloud where we have a lot more processing power in order to analyze and visualize the data. So this is basically the flow of data from devices to the cloud. I hope this answers your question.
Yes, yes. Thank you very much. So I think we can call it a day for at least the Q&A. The rest of the questions we are, ladies and gentlemen, the Schmersal team will get back to you. I now invite my colleague, Ms. Sana Baghdadi, to give the vote of thanks. Thank you.
A very good afternoon, everyone. On behalf of the Indo-German Chamber of Commerce, we would like to thank our knowledge partner for this session, Schmersal India. A sincere thanks to our panelists, Mr. Ranjit Kumar, Mr. Girish Lave, and Mr. Chinmay Vaidya, for coming on board and rendering us with a comprehensive and informative session. We extend a big thank you to all our esteemed guests for your active participation and listening so very patiently. A recorded link of today's session will be sent to you all. Please do write to us sharing your valuable feedback. In addition, I wish to express my gratitude to our IGCC team, Monaz, Samiha, and Nikhil for having successfully put this webinar together. As for our dear audience, please do visit our website to know more about the upcoming webinars and events, and we hope to have your presence and participation for our future events with the same zest as well. Thank you until next time.